Problem number 23, we're asked to graph a function, which is, in this case, linear, on the graph by making a table of values and then discussing the domain and the range. Okay, so to get these are our y values, remember, because f of x is equal to y. So what we're going to do is we're just going to take these values and we're going to plug them in. So we've got negative 2 times 3, that'll be negative 6. So I'll write that down. So it'll be 3 times a negative 2 minus 4 is equal to, so negative 6 minus 4, that'll be equal to a negative 10. Plug a negative 1 in here, and you're going to get out a negative 7, because 3 times negative 1 is negative 3, minus 4 is negative 7. Plug in 0. Okay. Notice how these are all increasing by the same amount. They're all increasing by 3, which makes sense because the only thing that's changing as we plug in x, as x changes, the 3 is going to impact it, but the 4 is going to stay the same. So we're good there. Okay, now we're going to graph it out. Well, this table asks us for ordered pairs, so we'll just write them in here. Negative 2, 10. Apparently, I need another coffee, I think is the deal here. Yikes. Okay, so 0, negative 4, 1, negative 1, and 2, 2. So we're just going to graph them. So we've got negative 2, negative 10. That's off of our graph, but we'll just eyeball her in there somewhere down here. At negative 1, we're at negative 7. At 0, we're at negative 4. At 1, we're at negative 1. At 2, we're up at 2. So we can see that we got this nice line here. So we're just going to go ahead and connect the dots as best we can. Ugh, that didn't look so nice. Let's try it again. Okay, look at that. Very good. Okay, so there is the graph of our function, and I put arrows on the end to indicate to the reader that it does indeed keep going in both directions. Now, domain and range. So domain are the x values. So again, I like to think like I am on the axis and I'm walking, and I'm going to look up or down. So for the domain, because the domain are the x values and the range are the y values, for the domain, I'm going to put my little person on the x-axis and I'm going to let them walk. Now the question is, if the little person looks up or down, do they see the graph? If they do, you include that number in the domain. If they don't see the graph, you don't include the number in the domain. Okay, so my little guy's here. Like if my little guy is right here, I'm gonna put him right here. My little guy's right here, and he looks up or down. Does he see a graph? Well, yeah, he sees a graph below him. So I'm going to include negative 2. What if he's at negative 1? Looks up or down? Yeah, he's going to see something. What about 1? Sure. What about 2? Sure. In fact, no matter where my little guy walks on the x-axis, he's going to see something. You might say, well, wait a minute. What if he gets way out here? How does he see something? There's no graph there. But wait. The graph extends up forever, right? So since the graph extends up forever, I don't know why I said it that way. Since the graph goes up forever, yeah, he's going to see something over here. It's going to be up above him. It's going to take a little while, but you'll see something. What about in the negative direction? Again, same deal. He's going to see something. It's just going to be below, but this keeps extending out forever in this direction. So any place that he's at on the x-axis, he's going to see the graph. Therefore, the domain is everything, the whole x-axis from negative infinity to positive infinity. And remember, we don't include infinity, so we put we put parentheses around the ends. Okay, now the range, I play the same game. for the range, except since the range is the y, I just tip my picture and I put my little guy on the y-axis. Again, if he looks up or down, no matter where he's at, from the most negative y, because this extends out forever, he's going to see something. And in the positive direction, since this extends out forever, he's going to see something. So every single y value is included in the range. So our range is from negative infinity to positive infinity.